All right, so welcome back to our OneClass channel. Again, my name is Joey. I'm going to be your math teacher for this session. So what we've been doing in our OneClass is we've been going over this process of verifying some commonly and frequently asked problems in mathematics and chemistry. And today what we're going to focus on is we're going to focus mostly on the math problems. I have about 10 problems for us, kind of ranging from high school level math all the way up to maybe something you might see in a university level math course. And then what we're going to do is we're going to explain to you the concepts and whatnot behind the questions so that you have the best solutions going forward. Again, my name is Joey. I'm currently an Ontario school educator with OneClass. And what I'm doing now is my teachable subjects are chemistry and music. However, I'm soon able to teach math in the Ontario secondary school level as well. So without further ado, let's get started on today's problem. All right, so our first problem we have, this problem says a question mark, but it's I scrolled down to see the solutions here, and it's asking us very much what is sine 3 pi over 4? And that's the question we're asking. That's the first question of the day. Or what is the exact value of sine 3 pi over 4? So this is some type of question mark, so we don't know this. So what we're doing here is, this is a question that you would probably find in grade 11 context in the trigonometry kind of unit, when we're asking about how to first look at 3 pi over 4 and recognize that it's in radians, and then also how do we find equivalent trigonometric ratios in order to solve this problem here. So what we're going to do first for this problem is how do we find sine 3 pi over 4? Well, we have to write down our axis first, right? So let's draw our axis here. So we have 0 and 2 pi on this line here. We have pi over 2 on this line. We have pi here, and this guy has to be 3 pi over 2. If you're thinking in terms of degrees here, this is 0 and 360. This y here would be 90. This guy here would be 180. And this guy here would be 270 degrees. But however, we're going to look at radians. So I would like to draw this in radians because our problem is also in radians as well. So as you can see, 3 pi over 4 here, if we want to determine where this is on the axis, what we can do is we can actually use 3 pi over 4. And you can see it's kind of close to 4 pi over 4 here. Or let me do a 4 pi over 4, which is this is equal to pi. So 3 pi over 4 is just simply a little less than pi. So I can say that 3 pi over 4 is less than pi, which means my angle is going to exist over here. Let me see if I can draw a straight line here. There we go. So this angle theta here is going to be theta equals 3 pi over 4. And the equivalent angle of this is going to be, let me write down, use another color here. This angle here is going to be pi over 4. So I'm going to say here angle 1 here is going to be pi over 4. So again, now we found our equivalent angles, right? Because again, this entire angle here is 3 pi over 4, which means this angle must be pi over 4, right? Because 3 pi over 4 plus pi over 4 equals pi. So that's how we know that these two angles are equivalent. And what we can do now is we can actually use our equivalent trigonometric ratios. So we know that first we have to figure out our CAST rule, right? And our CAST rule is simply just a mnemonic for us to figure out in which quadrants specific trigonometric ratios are either positive or negative. So this here is a C, this here is A, this here is S, and this here is a T. So C for cosine, A for all trigonometric ratios, sine for sine, and T for tangent here. Or sorry, S for sine and T for tangent here. So what we can do now is we can figure out, okay, where does our angle lie in? Well, we know that it's going to lie in quadrant 2, right, where the sine quadrant is. So we know that sine here is also going to be a positive value. if this angle was in the tangent or the cosine area, or in the quadrant, sorry, it would be a negative sine ratio. So we know that now. We know that sine here is positive. So what we can do now is we can actually take our equivalent trig ratio and actually apply our special triangles for us to figure out what this is here. So we're going to take pi over 4 as our equivalent trig ratio. Now, before we solve this problem here, what we can do is we know that we need one more piece of information to solve this problem, and this here is our special triangles. So special triangles here, for specifically this case, we care about pi over 4 or 45 degrees. So this here is going to be a pi over 4. So both of these guys here are pi over 4, and we know that in a 45, 45, and a 90-degree angle here, we have 1, 1, and root 2. So we have these, so this here is our special triangle, which means now we can solve for what this guy is, right? So sine here, so sine 3 pi over 4 is going to be equivalent to the sine pi over 4 in the second quadrant. So we can say this is going to be equivalent to sine pi over 4. And this is going to be, again, positive because I said that this lies in the positive, in the second quadrant, which makes sine positive. So we can say sine pi over 4 equals, so now all we have to do is simply just plug in our trig ratio, right? So we know that it's going to equal opposite over the hypotenuse, which in this case here, we have opposite here, which is going to be 1, and the hypotenuse here, which is root 2. So we have, this is going to equal 1 over root 2. So at this point, what you can do, you can leave this answer as 1 over root 2, or you can rationalize it by multiplying root 2 to both sides, or to the top and the denominator. So you get root 2 over root 2. So this is sine pi over 4, and this is also sine pi over 4. Which means if I know that sine pi over 4 is 1 over root 2, then therefore I can say that sine 3 pi over 4 is also equal to 1 over root 2, or root 2 over 2. And this here is going to be the solution for our first question. So let's look at the problem. Let's look at the problem now, and let's look at how they got to this answer here. So what they did here was they explained what sine, the trigonometric ratios first, and then they figured out in terms of our opposite, adjacent, hypotenuse, where the ratios are. And they have in degrees here, but we're actually going to do it in radians. So this here, yeah, they converted to, what they did was they actually converted to degrees first. I prefer working in radians because most grade 11 students will have to work in radians eventually. So this here is good if you're working in degrees, but I prefer working in radians in this case. But so I didn't have to do this step if I knew where the quadrants were. So if you don't know how to work in radians, or if you're a little bit uncomfortable with doing that, what we can do is we can actually convert radians into degrees by simply multiplying by 180 degrees over pi. But you're going to realize that 3 pi over 4 actually exists in the second quadrant, so at 135 degrees. So in this quadrant, so which is good. And what we can do now is we can look at what they did here was they actually plugged in their equivalent trig ratio, right? So they plugged in this first equation, trig ratio here, which is sine 180 minus theta, or angle A, equals sine theta. So we know that in this quadrant here, sine is also positive. So they know that sine 135 is equivalent to sine 45. And sine 45 here is simply just pi over 4. So as you can see, they wrote that sine 45 is 1 over root 2, which is our answer here. So therefore, sine 3 pi over 4 is also 1 over root 2. So the solution here is correct. I personally don't like, I like their solution here, but I prefer that if they worked in radians, it might have been better, just because it's a little bit confusing when we're talking about, when we're converting from sine 3 pi over 4 to 135, and then sine pi over 4 back to 45 degrees. So this solution here is correct, but I wish they kind of stayed in their, in radians instead of degrees here. So that's all I have here. So solution, good analysis. So solution here is correct. All right, question 2. Question 2 is asking, how do you express 48 out of 60 as a percent? So we can do this as number 2. So I want 48 out of, let me scroll up just to get some space here. No. So I have 48 out of 60 as a percent. So what we can do here is we can first create a fraction, and then what we can do is we can create a percent out of that fraction here. So 48 out of 60, we can rewrite this as 48 as the numerator and 60 here as the denominator, right? What's 48 out of 60? Well, it's simply 48 over 60. And because 60 here represents the big part and 48 represents the smaller part, right? So we have 48 over 60. And what we can do here now is there's a lot of ways to do this. We can convert this into a decimal and then to a percent, or we can actually directly convert this into a percent. In this case here, I'll convert this to a decimal first and then percent to show you like one extra step as in terms of how you would do this problem. So first, what I would do, I would reduce this guy. So at 48 over 60, I can divide both of these guys, I believe, by 4 to reduce this. So this would equal the top would equal 12 and the bottom would equal 15, I believe. And then we can actually divide again by 3, right? 12 and 15, the greatest common factor here is 3. So this would be simply just 4 over 5. And once we have 4 over 5 as a fraction, well, this is now an easy conversion, right? With 4 over 5, I mean, we can multiply it by 100% to solve for our percent, or we can change this to a decimal. I simply just have to multiply by 100 here, right? So I'm going to multiply by 100%, and this is going to give me, again, I can cancel out the 5 here. This becomes 1, and 100. If I divide 100 by 5, this becomes 20, right? So all I'm left with is 4 times 20 here, which is going to equal 80 here. And this would be 80%. Or you can say that it's going to be, if I were to convert this to a decimal, this would be 0.8. So this answer, how do you express 48 out of 60 as a percent? So therefore, 48 out of 60 is 80%. So as you can see, this is the correct solution because they wrote 80% as well. So solution is correct. All right, number 3 is asking us how many cups are in 1/2 of a gallon. Cups in 1/2 of a gallon. So what we're doing here is we're just simply using some measurements and some unit analysis. So we can look at cups and gallons here, and we're going to recognize that we're working in the imperial system. And we're also measuring our volume here. So what we're going to have to know is we're going to have to actually memorize some stuff here. We're going to have to memorize a table for our commonly used conversions between gallon and between units of volume here in the imperial system. So what we can do first is we can write out our conversions here. So we know that 1 gallon is going to equal 4 quarts. 1 quart is going to equal 2 pints. 1 pint equals 2 cups. So what we have here is we want to convert from gallon, we have 1 gallon, or sorry, 1/2 a gallon to cups, right? So from, highlight this here, from gallon, so this is gallon, all the way down to cups here. So what we're going to have to use, we're going to have to use some unit analysis. So I'm going to start off with 1/2 a gallon. So I can write down 1/2 a gallon. I'm going to multiply that by, I know that 1 gallon here equals 4 quarts, right? So I can multiply these gallons by, I know that in 1 gallon I have 4 quarts. So 4 quarts in 1 gallon. Afterwards, I know that I have 2 pints in 1 quart, right? So I can multiply this again by, I have 2 pints in 1 quart. And then in 1 pint, I have 2 cups, right? So I can say that I have 2 cups in 1 pint. So what we have here now is our gallons are going to cancel out, the units for gallons. Our quarts are also going to cancel out here. And our pints are going to cancel out. So what we're left here is we're left here with cups, which is what we want, right? We want to find out how many cups are in half a gallon. So we're simply just doing this operation here. We have half times 4 times 2 times 2. And this will give us how many cups are left here. So half times 4 is 2. 2 times 2 times 2 times 2. 2 times 2 here is 4. And then 4 times 2 here is 8. So therefore, there are 8 cups. So 8 cups in half a gallon. So this here is our solution. As you can see, this solution is correct. We have half times 4 quarts over gallon times 2 pints over quarts times 2 cups over a pint. And this is actually the greatest solution because this here is a very good example of U analysis, which is going to equal 8 cups. The solution here is correct. That's number 3. Number 4. How do you find the square root of 36? So when we're talking about the square root of something, we have to think about what, mathematically, it means it's this little like umbrella or this little roof above a specific number. So this here is the square root of 36. And how do we solve this problem? Well, there's a couple ways to solve this problem. If we're looking at from a lower level math perspective, here what we can do is we can implement something called a trial and error to solve for what 36 would be. So when we're talking about square roots of something, we are talking about the inverse operation, which is taking the exponent of 2 or squaring a specific number. So if we're going to use a trial and error method, what we can do is we can simply write down all the square roots or all the squares and see what the square roots are going to be. So I have, so I'm going to have 1 squared here, which is going to be 1 times 1, which is going to equal 1. 2 squared is going to be 2 times 2, which is going to be 4. 3 squared is 3 times 3, which is equals 9. 4 squared is 4 times 4, which equals 16. 5 squared equals 5 times 5, which equals 25. And 6 squared equals 6 times 6, which is going to equal 36. Now we're going to stop there because we recognize that 36 here is the number in our square root. So this is going to, so if I know that 36 here equals 6 squared, then what I can do with this algebraic equation is I can actually take the square root of both sides, right? I can square root 36 here, and I can do the inverse operation. So I can square root 6 squared here, and the exponents to the 2 and the square roots are going to cancel out here. So this here, and I told you that it's the inverse operation. So therefore, square root of 36 is simply going to equal 6. So this is our answer here. So square root of 36 equals 6. So this method only works if you're talking about a perfect square root, where when you square root a number, you're going to get an integer or a whole number here. So in this case, this method works. If we had a number that was not a perfect square root, we would actually have to find the prime factors of 36 and break that down into its prime factors. So let me do this problem again, and I'm going to show you what I mean by breaking it down into prime factors. So assume that we're not going to use our trial and error, so we don't know what the square root of 36 is. So we're going to take this number 36, and we're going to find all the, we're going to find the factors of 36 here. So as you can see, the factors of 36, this number is divisible by 3, right? So I can take out a 3 here. So it's going to be root 3 multiplied by root. And what's 36 divided by 3? Well, 36 divided by 3 equals 12 here. And then we do the exact same thing with the bigger number, right? So root 3 can also go into 12 here is divisible by 3 or also by 2, right? So let me take out a 2 here. Or let me take out a 3 here because it's, or actually let's take out a 4 here because this here is our greatest common factor of 12, right? So let's take out a 4. So we have square root of 4. 12 divided by 4 is simply equals to 3. So now I have, root 36 is going to equal root 3 times root 4 times root 3. Which is the same thing as if root 3 times root 3 here, this is going to equal root 9 times root 4. If I simplify these two guys here. And I know that root 9 here is going to equal 3, right? And root 4 equals 2. So therefore, it's 3 times 2, which is going to equal 6. So that's how you would break this down into its prime factors, knowing given this as well. But at the end of the day, you still don't need to know that root 9 here equals 3 and root 4 equals 2. Because again, these are smaller numbers, and I would expect most students to know the square root here. But either way, both answers lead to 6. And in this case here, it's actually plus or minus 6 here. So if I were to be technical, this should be plus or minus 6 because negative 6 times negative 6 also equals 36. And 6 times 6 here equals 36 as well. So our answer technically should be plus or minus 6 depending on, and it depends on the question whether or not we take the positive or the negative one. But for our purposes, we're going to say it's plus or minus 6 here. So solution here is correct. Okay, next question. So here's number 5. So number 5 is asking define complex number in standard form. So complex numbers in standard form. So what we can do here is they actually give you a really, really nice solution here, and I'm going to explain the solution as well. So it says a number of the form z equals a plus ib is known as a complex number. So z, which is the common kind of, which is basically any number. It could be real or imaginary here, or complex. Z here equals a plus ib. And and how we break this down is we have z here, which is basically our, like any number here. A here is going to be the real part of our number. So a here is the real part. So anything that's a real number. And then b here is also our real part. And I here represents our imaginary number. So that's going to be our complex part. So I here is defined as the square root of negative 1. And this here is universal because we're working out in the complex plane. If I take the square root of negative 1 here, I'm going to get an imaginary number. So this here is I. So a and b are real numbers. Sorry, this is are real numbers. But a here is the real part, and this here is the complex part. But a and b are both real numbers. So sorry for the confusion there. So for example, if I were to write, let's say z here equals 3 minus 2i. Well, I know that this here is a complex number in standard form. And I can break this down into our real parts, right? So if I were to plot this, I can say that this guy here is this, or this guy here would be A. This guy here would be B. So I have, this number would be, if I were to write it in a coordinate form, this one would be 3 and negative 2 here. And if I were to plot this out in a real and imaginary plane, so this one would be in the real plane, this here would be the imaginary plane. I have 3 here, which is going to be, let's say 1, 2, and 3, and negative 2, so 1 and 2. So this here is negative 2, so I would have something like this, approximately. So this would, it would be a vector going from the 3 right to the real plane, and then 2 down in the imaginary plane. So this would be considered, so z minus 3, or z equals 3 minus 2i, here would be considered a standard form of a complex number. So it's basically, in summary, you have z here, which is going to equal a real part plus an imaginary part. A and b are real numbers, and I here is the imaginary part. And we can graph this in terms of real and in the real and the imaginary plane. But this here is the standard form of a complex number. So the solution here is correct. All right, number 6. You need to rent a moving truck for 2 days. Rider moving trucks charges $50 per day and 50 cents per mile. You move trucks charges $45 per day and 75 cents per mile. So let me draw this out first. This is question 6. So I have one company that does $50 per day plus 50 cents per mile. I have one that does $45 per day plus 45 cents per mile. It says write an equation describing each situation. So let's look at the first situation here. So I'm going to write this as, here is A. Here's B. So let's look at A here. At A here, I don't want to adjust my brush size here. A is $50 a day. So we can write this in terms of a standard form of a linear equation, right? So we have A here is going to equal y equals mx plus b, which is our standard form of a linear equation. And what we have here is this y is going to equal the slope, right, which is m. In this case, the slope here is going to be my rate of change, which is going to be 50 cents per mile. So in this case here, my slope is going to be 50 cents, or 0.50 x plus, we have b here, and b is going to represent our initial cost, right? And the initial cost per day is $50 per day. So if you were to not even drive a mile, and if you rent a truck, it's still going to cost $50 a day. So I'm going to add $50 here. And let's look at B. So this is the equation for the first one. Let's do B in a different color. So let's do this one in a different color. So I'm going to have y, again, y equals mx plus b. Y here is going to equal, for the second situation for B, it's $45 per day plus 45 cents, or 0.45 per mile, right? So which means the exact same thing. The slope is going to be our rate of change, which is 0.45 x plus, and our initial cost for B here is going to be, instead of $50 per day, it's going to be $45 a day. So that's the, so we now have an equation describing each situation. We have to graph them on the same x and y axis. So let's graph this. And it might be a little bit messy because I'm kind of sketching these graphs here. But so I'm going to say that this here is my x and this here is my y. So I'm going to have I'm going to have A here, which is it's going to start at $50. The y-intercept is going to be 50. So this is 50. This is going to be 45, something like that. And then what we can do is we can either do a rise over run to figure out what the next point is, or what we can do is we can just sub in an arbitrary x number to figure out what the next value is. So in this case here, I'm just going to sub in, let's say we drive 50 miles for each of them. So I'm just going to sub in another point here. So let's say if x here equals 50, what is y? Y here is going to equal to 0.50 times 50 plus 50, right? 0.50, or half of 50 here is 25 plus 50, which is going to equal 75. So in this case here, I'm going to say that this here is a 50. So in the first guy here, it's going to be 75, right? So it's going to be 75. And then for the second one, I'm going to have, again, y equals 0.50 times, y equals 45 times 50 plus 45. Oh, sorry, this is 0.75, not 45. Let me change that here. It says 75 cents here, right? My mistake. So 75 cents times 50 plus 45. So 0.75 times 50 is going to give me 37.5 plus 45. This is going to give me a value of 82.5. So I'm going to have to actually redraw my axis here because this looks really messy here. So let me do that. So this is going to be at 50 miles. So initial here is, I think it was 45. This here is 50. And then for the 50 guy here, I'm going to have 75. So this one would be like 75 here. And the next one is 82.5. 75. Let me do the first equation in pink. So this would be 50 and 75. And then the second one in green, 45 and 82.5, which is going to be here. So I'm going to have one guy that kind of looks like this, and the other guy kind of looking like this, something like that. It might be a little bit better if I use a proper scale, because this here is not a great scale. So let me actually just let me draw this out on Desmos, because again, this sketching here is pretty, it doesn't look very nice because I don't have a scale. So it might throw you off in terms of like what we're doing here. But as long as we have 2 points, what we can do, the concept is we can actually plot this graph, right? So we have 45, we have y equals 45 and y equals 82.5 at 50, and then y equals 50 and y equals 75 here. So we have 2 lines here, which means we can draw. So we have 4 points, so we can draw 2 lines here, and that's kind of the concept for this. But let me use Desmos to show you what this graph actually looks like. So I have y equals, or I have 0.50x plus 50, and the second one here is I have 0.75x plus 45. So it looks something like that. So kind of like what I did before, but with a better scale here. So I kind of drew my graph like that. But this here is a better graph than my graph, obviously, because I'm sketching it. But that's kind of what we want to visualize here. And saying, so we have graph, so we're good. It's asking from your graph after how many miles would the trucks cost the same? So that's A. So if we want to find that out, what we can do is we can simply, we have 2 equations here, and we can actually use substitution, right? We can substitute one equation into the second one and then solve for our x value. So that's how you would do it algebraically if I were to solve for this instead of graphically. So I'm going to have 0.50 plus 50 equals 0.75x plus 45. I can move all the x's to one side, so I'm going to subtract 0.75x from both sides get negative 0.25x on this side. Plus 50 is going to equal 45. 0.25x equals 45 minus 50 here. I'm going to minus 50 from both sides, which is going to give me negative 5. X is going to equal negative 5 divided by negative 0.25, which I believe is 20. Yes, 20. So basically, if I were to equate these two, the point of intersection for both these lines are going to be at 20 degrees, or at 20. So this point should be at 20. So in 20 miles, the trucks would actually cost the same. So it's asking here is, which company will give you a better deal if you drive less than 30 miles? Well, if you drive less than 30 miles here, the better deal would be the B line, right? The second company here, because if I drove less than 30 miles here, the initial cost is going to be, it's going to be equation A here, not equation B, equation A here, because the slope here is less steep than 0.75 here, right? So although you're paying more for the initial cost here, which is $55 more, you're driving less miles. So the slope here, the 0.5, the rate of change here is going to be less. However, if you're driving more, C here, which company will give you a better deal if you drive more than 60 miles? Well, for more than 60 miles here, I think this is 0.75 this is 0.75 plus 75, sorry. It's asking which company will give you a better deal is actually B. Because again, although the rate of change here is steeper, but you're paying less for the initial cost. And then for C here, it's going to actually be the first company, because although you're paying more for the initial cost, you're actually paying less because you have a rate of change that is less than 0.75. So for B, the second company is cheaper, and the C, the first company is cheaper here. And we can actually plug this in. We can plug in 30 for X here to solve, to figure out which one would cost more, but we could also look at the graph here. So let's look at the graph here for B and C. So which company will give you a better deal if you drive less than 30 miles? So let's look at our X values here, and let's say we're driving less than 30. So this here is the 30 line for both here. So I want, obviously, if I'm driving less than 30 miles, the cost here of the blue line is much greater, right? So I would follow the cost of the red line, which is going to be the first company, like I said before. Even though the initial cost is higher, I'm driving less miles, so it doesn't matter as much. But then if I were to be driving 60 miles here, I can zoom out here and look at 60. So this here is 60. As you can see here, the blue line is now much steeper than the red line here. So the cost here, the cost of this line here is going to be, less for the orange line here. So the first company here is going to be cheaper. So 30, but if I were to be driving less than 30 miles here, the blue line is cheaper, right? If I'm driving 20 or less, the blue line is definitely cheaper here as well. So this solution, I think this is supposed to ask us 20, because that's the point of intersection, but that's okay. This here is a solution. Again, they wrote the solution correctly as well. I believe it's 90. Oh, this is 90 and 100. So I don't think they actually graphed this correctly. It's $50 per day and $45 per day here. So this graph is actually wrong. This is supposed to start from 50, and this is supposed to start from 45. So they actually graphed this wrong here. So let's see. Let's look at their answer here. At 40 miles, both trucks are $120, and as I told you that it was at 20 miles, so they actually wrote the wrong values here. For less than 30 miles, U-Move is better. For 60, Ryder is better. So U-Move was the second company, and the Ryder was the first company. So the solution is actually incorrect because they failed to plot the graph correctly, and it's at 20 miles. The costs of both trucks are the same, right? So I'm going to write solution here is incorrect. The graph is incorrect because the y-intercepts are supposed to be at 25 and at 50. At 20 miles, the costs of both truck companies would be the same. So the solution here is incorrect. Okay, that was number 6. Let's look at 7. How do you simplify and make the fraction 5/12 into a decimal? So what, 5/12 as a decimal? So what I have to do is I would have to actually look at, I would have to, if I were to convert fractions to decimals, I would actually have to use, I'm using long division. So 5/12, so 12 is going to be my, my divisor here, and 5 is going to be my dividend. I'm going to add some zeros here. And then we're simply just trying to find the quotient here, which is going to be our decimal, right? So 12 times what number is closest to 50? In this case here, 12 times 4 is 48, right? So 0.4. 12 times 4 is going to be 48. And then 50 minus 48 here is 2. Bring down the 0. 12 times what number is close to 20? Well, I can only put 1 of 12. So 20 minus 12 here is going to be 8. Bring down the 0 again. 12 times what number is close to 80? So I believe it's 6, because 6 times 12 is 72 here. 6 times 12 is 72. 80 minus 72 here is going to be 8. You can bring down another 0, and you're going to recognize that the 6 is going to be a repeating decimal. So in this case here, 5/12 as a decimal. So therefore is, so it's going to equal to 0.416, and this is going to be a repeating decimal here. So 0.416 repeating. So the 6 is going to the top. And as you can see, the solution is correct, 0.416. And the dots represent, the dots here represents that it's going to be a repeating decimal here. So the solution here is correct. So that was number 7. Let's look at number 8 here. What is the square root of 125 over 5? So the square root, again, you can see the square root again, of 125 over 5. So what we can do first is we can actually simplify whatever is in the with the number that's being square rooted, right? So we have 125 divided by 5 here. So let's do that operation first. So what's 125 over divided by 5? Well, let's do that on the side here. We have 125 and 5 here. So 5 times what number is closest to 12? 5 times 2 is closest to 12 here. 5 times 2 here is 10. 12 minus 10 here is going to be 2. You can bring down the 5 here. 5 times what number equals 25? I know 5 times 5 equals 25, right? So 25 times 5 is going to equal 25, or 125. So therefore, I can say that's the square root of 25. And we know that the square root of 25 here is going to equal 5. So this is our solution, because 5 times 5 is equal to 25. So number 8 here, what is the square root of 125 over 5? Is going to equal 5. So this solution is also correct. Sweet. So that's number 8. Let's look at number 9. The length of a rectangle is 5 inches longer than half of its width. The area of a rectangle is 72 square inches. How many inches wide is the rectangle? So let's draw this rectangle first, and let's visualize this. We have some type of rectangle, and it says here the length of the rectangle is 5 inches longer than half of its width. So we have a width here, some type of W, and the length here is going to equal, it says here, 5 inches longer than half of its width. So a half of its width, half times W, plus 5 inches longer, right? So we have these two guys here, and the area is 72 square inches, right? So how many inches wide? We want to determine the width of the rectangle. So knowing our equations here, the area of a rectangle equals length times width, right? So area here is going to equal length, which is equal to half of the width plus 5. Times W, right? So L here is half W plus 5 here. And we know that area here equals 72, right? So we know that 72 is going to equal half times W plus 5 times W, right? So now all we have to do is now just isolate for our W here. So let's do our operations. So we have 72 equals, so we're going to use distributive property. So half W times W is half W squared. And then 5 times W is simply 5W, right? And then what we can do now is we can actually bring 72 on this side to create a quadratic equation. So 0 equals half W squared plus 5W minus 72. And this here is going to be our quadratic equation. What we could do here is we could try to factor, or we could just use the quadratic equation. I would simply just use the quadratic equation in this case because my a value, this leading variable here, is not 1. So I would just use the quadratic equation. So I'll do some blue, and kind of greenish. So W is going to equal plus negative b, sorry. So negative 5 plus or minus the square root of b squared, which is 5 squared, minus 4ac, so 4 times half, times c here, all over 2 times half, 2a. So negative 5 plus or minus, this is the square root of 25, 5 squared is 25, minus, I have 4 times half here, which is 2, times 70 times 72 here, which is going to give me 144. And that is going to give me an imaginary number. So actually, I might have done something wrong here because I shouldn't get an imaginary number here. So let me just erase this real quick. And let's actually go back and figure out what we did incorrectly here. So let's see. Length of a rectangle is 5 inches longer than half of its width. So half width plus 5. And we have here's the width here. 72 is the area of half W plus 5 equals W. Half W times W is half W squared plus 5W. So I should have made my equation good though. So maybe I did something wrong with the quadratic formula. This is negative b. So negative 5 plus or minus the square root of b squared, which is 5 squared, minus 4 times a times negative 72. So there's a 5 here. Just give me a second. 0.55 negative 72. So let's see. Let me just look at the solution to see whether or not they got this right as well. So they wrote L here equals 5 plus W and not a half W plus 5. It's saying here the length of the rectangle is 5 inches longer than so they forgot actually half of its width here. So because of that, they actually made the wrong equation. They wrote L equals W plus 5 when it's supposed to be half of W plus 5 here. So this solution is immediately incorrect. So I believe that the steps are correct, but they didn't write half of the W as well. So I believe that my solution here is correct here. And I'm just trying to figure out how to get rid of this imaginary square. Because I'm going to have negative 5 plus or minus 25 minus 144, I believe. Oh no, this is negative 72. I forgot to put the minus here. So this is actually going to be plus 144. There we go. Times 2 times half. Sorry about the negative sign here. So this is going to equal -5 plus or minus 25 plus 144 is going to be 179. 2 times half here is simply just 1. So I have -5 plus root 179, or -5 minus root 179 here. And this here is going to give me the square root of 179 is going to give me, or sorry, 140 is 169. Oh, it's a 179, sorry. Let me erase these guys here. So this is the square root of 169. Square root of 169 is going to be 13. So -5 plus 13, -5 minus 13 here. -5 plus 13 is going to be 8, and -5 minus 13 is going to be -18. So again, because my length cannot be, or my width cannot be negative, 8 is going to be my correct answer. So the width of the rectangle is going to be, W is going to equal 8. So that's going to be my answer for this problem. And it's asking how many inches wide is rectangle. So width here is 8 inches. So therefore, width of rectangle equals 8. So we say, so the solution here is incorrect. Incorrect solution. Length should equal 0.5 width plus 5 instead of L equals W plus 5. And then I'm just going to quote this. We are missing the half of its width in your equation. Therefore, the answer is 8 inches for length of the rectangle. So the solution here is incorrect. And then finally, I can do number 10 quickly. The next couple of minutes. It's asking us which Pythagorean identity is correct. So I'm giving a list of all these Pythagorean identities here. So let me just prove some of these guys here. As you see, it says option B here is the correct answer, and let's verify that. So I have A here, or let me just verify. Let's just verify the option B here to make sure that the solution here is correct. So B is stating that it gives me tan squared theta equals, or plus 1 equals secant squared theta. So what we can do first is we can actually change tangent into sine and cosine. So we have sine squared over cosine squared plus 1 equals secant squared. And then what we have here is, what we can do is we can actually disperse this one into its common denominator, right? So I can write everything in terms of cosine squared. So I'm going to have sine squared at the top, like always, and then add also a cosine squared as well, because cosine squared divided by cosine squared is simply just 1 here, right? This is going to equal secant squared. And what we can do here is I can see that I'm going to have sine squared plus cosine squared is going to equal 1, right? Because of my first Pythagorean identity, right? We know that sine squared theta plus cos squared theta equals 1. So therefore, we're going to have 1 in terms of the numerator over cosine squared theta, which equals secant squared theta. And we know that secant squared theta is simply just 1 over cosine squared theta. So this solution is correct. So left side equals right side. So this here is a good solution. So we know that secant is, again, our secondary trigonometric ratio, or the reciprocal, of cosine squared theta. So the solution here is correct. So B is the correct Pythagorean identity. So again, thank you so much for watching this video. Again, my name is Joey. I only stream 2 days a week now, just because I'm a little bit more busy. I stream math on Mondays and chemistry on Wednesdays, and you can come check me out then. All these videos are posted on youtube.com/OneClass, so you can go and watch those videos or keep up with the stream as we go along. Again, thank you so much for watching. Stay safe, stay healthy, and have a great day. Take care.